Alrighty, so we are going to start section 4.4. Well, we're going to do the whole thing. We're not just going to start it. 4.4 is all about being able to build a polynomial given the zeros, or if we're not given the zeros, being able to take a polynomial and break it down into its factored form and find the zeros. Okay, so first we're going to start, excuse me, we're going to start with building it up. Okay, so in order to find a polynomial given specific zeros, what we're going to do is we're going to use each zero to make a factor. Okay, and then we're just going to multiply out all of those factors to figure out what the original polynomial was. So let's look at some examples. On this one, we're given the zeros -3, 2i, and -2i. And it says we want to find a polynomial function of degree 3. So when you see degree 3, that means we should end up with an x cubed as our highest power. Okay? So if it's telling us we ended up with these zeros, what that's saying is that we ended up with x equals -3, we ended up with x equals 2i, and we ended up with x equals -2i. Okay, so remember, when we take our solutions, or rather when we take our factors and we solve them, we set each factor equal to 0 to get our solution. So if we're given a solution, we can take our solution and move it back across the equal sign so that it's equal to 0. So here we would get x plus 3 equals 0, right? Here we would get x minus 2i equals 0. And here we would get x plus 2i equals 0. So these are the factors we would have had to set equal to 0 in order to end up with these solutions, right? So that tells me that the factors of this polynomial, we're just going to call it p of x, would be x plus 3, x minus 2i, and x plus 2i, right? And so if they want us to find the polynomial, all we have to do now is multiply it out. Now, anytime you have factors with nasty things in them, like in this case we have i's, in the next one we're going to have radicals, okay, always multiply out the two that are the grossest looking first, because usually that will take care of the nastiness. So we still have this factor, x plus 3, and we're going to have to multiply that by whatever we get when we distribute this. So x times x gives me an x squared. X times 2i gives me a positive 2xi. And then I move on to distributing my negative 2i. Negative 2i times x is negative 2xi. And then negative 2i times positive 2i is negative 4i squared. Right? And there's a little bit of simplifying I can do here, because notice my xi terms are opposites, so those are going to combine to 0. And then remember, I squared is equal to -1. So if I take this -1 and multiply it by the -4, that means this becomes a positive 4. So I have x plus 3 times x squared plus 4. And then all I have to do is distribute, right? So x times x squared gives me x cubed. X times 4 gives me 4x. Then I distribute my 3. 3 times x squared is 3x squared. And 3 times 4 is positive 12. Now, it shouldn't count you wrong if you enter it like that in my math lab, but it is a really good habit to get used to writing our polynomial functions in descending order, meaning our highest power of x down to our lowest. So I'm going to go ahead and write it with my x cubed, then my x squared term, then my x term, then my constant term. And this is the polynomial that if we were to completely factor it would give us the zeros -3, 2i, and -2i. Okay, so we're kind of going backwards from what we've done. Starting with the answers, creating factors, using those factors to come up with the original polynomial. Okay, and we did end up with a degree 3 polynomial because we have an x cubed. Okay, let's look at the same idea on this next one. Excuse me. So this means that we ended up with x is equal to the square root of 2 x is equal to the negative square root of 2, and x is equal to 3. So now we have each of the solutions written out. So to find the factors that these solutions came from, we would have to take each little value and move it back across the equal sign. So this means x minus the square root of 2 equals 0, x plus the square root of 2 equals 0, and x minus 3 equals 0. So we can easily see what our three factors would be. So we're going to go ahead and say that this polynomial p of x can be built by multiplying x minus the square root of 2 times x plus the square root of 2 times x minus 3. And just like on the last one, we had nasty factors that had i's. In this situation, we have nasty factors that have radicals. So we're going to start by multiplying these two nasty factors together first, right? So x times x gives me x squared. X times positive square root of 2 is positive square root of 2x. And then negative square root of 2 times x is negative square root of 2x. And then negative square root of 2 times positive square root of 2 gives me negative square root of 4. And it's still being multiplied by this x minus 3 factor at the end. So again, I should have some simplifying to do. My square root of 2x terms are opposites, so those cancel out. And then I can simplify the square root of 4. This just becomes x squared minus 2 times that last factor, x minus 3. And then we just need to distribute it. When I distribute my x squared times x is x cubed. X squared times negative 3 is negative 3x squared. Then I distribute my negative 2. Negative 2 times x is negative 2x. And negative 2 times negative 3 is positive 6. So we want to go ahead and label that with our polynomial function. And this is the polynomial function that would yield these three zeros. Okay? All right, I want to show you one more that's the same idea of building up this original polynomial, but instead of them just stating the zeros, they're going to give that information to you in a little bit different way. So on the top of the next page, you can see here, they're still giving us these zeros. Oh, no. Am I missing a page? Oh, here we go. Here we go. On the top of this next page, it says find a polynomial function of degree 5. That means we should be ending up with an x to the 5th power, right? With negative 1 as a zero of multiplicity 3. So I'm going to stop right there. Negative 1 as a zero. That means negative 1 is a solution, okay? So we're going to say x equals negative 1. And its multiplicity is 3. So multiplicity 3 means when I write this as a factor, which I can write it as a factor by taking that negative 1 and moving it back across, so we'd get x plus 1. If it has multiplicity 3, that means that that factor is cubed. Okay. Then I want to do the same thing with the next one. It says I have 0 as a zero of multiplicity 1. That means I ended up with x equals 0. And if it has multiplicity 1, then I only have one copy of the factor that it came from. So notice here, if I were to move this 0 over by subtracting it over, x minus 0 is still just x. So this would just be the factor x. And then the last one is 1 as a 0 with multiplicity 1. So that means we ended up with x equals 1. It has multiplicity 1, which means the factor that it came from, I only had one copy of it. And the factor that this came from, if I move the 1 back across, would be x minus 1. Okay, so I'm going to get my polynomial function here by multiplying all these together. Now, I always like to write my monomial term first. So I'm going to write x out here, and then x minus 1, and then x plus 1 cubed. And now I just need to multiply all this out to see what it equals. Okay, and I'm going to do that over here. And if you tend to write big, write small. I really just did not leave enough space here. So I have x times x minus 1, and then x plus 1 cubed means I have 3 copies of that quantity, right? So this is what I need to multiply out. I'm going to start with just the first two. So when I distribute my x in here, I'm going to get x squared minus x. And then I'm going to go ahead and write on the other three factors I still have out here. And now again, I'm going to just do the first two together. So when I distribute my x squared times x is x cubed. X squared times 1 is x squared. Then I have a negative x times x, which is a negative x squared. And then a negative x times 1, which is negative x. And I still have my other two quantities out here. And notice in this first quantity, my middle terms are opposite. So those actually combine to 0. So I'm going to go ahead and just mark those out so that I know I don't have to distribute them in the next step. Okay, so I'm going to go ahead and multiply these two together now. So when I distribute my x cubed times x is x to the 4th. X cubed times 1 is x cubed. Now these two canceled out, so I'm just going to distribute my negative x. Negative x times x is negative x squared, and negative x times 1 is negative x. And then I have one more factor here on the end to multiply it by. Okay, so I need to multiply all of these by x and then all of these by 1. Okay, so when I multiply all of these terms by x, I'm going to get the same thing, but their exponents are going to increase by a power of x, right? So x to the 4th, x cubed, negative x squared times x, and if I negative x, all multiplied by x is going to give me x to the 5th plus x to the 4th minus x cubed minus x squared, right? So I just multiplied all of these times x. Now I just need to multiply all of these times 1. And when I multiply all of these times 1, I'm just going to get all of these, right? Which is a positive x to the 4th, positive x cubed, negative x squared, and a negative x. Okay, so this is my polynomial. I just need to combine my like terms. Okay, so this means I end up with p of x is equal to, my highest degree term is x to the 5th, right? And then x to the 4th, I have a positive x to the 4th and a positive x to the 4th, which is going to give me 2x to the 4th. Then I look for my x cubes. I have a negative x cubed and a positive x cubed. So those are actually opposites that cancel out. Then I look for my x squareds. I have negative x squared and negative x squared, which gives me negative 2x squared. And then the last term I have is my negative x over here, minus x. So this is the polynomial function that would produce a degree 5 polynomial function, right? With negative 1 as a 0 of multiplicity 3, 0 as a 0 with multiplicity 1, and 1 as a 0 of multiplicity 1. Okay? All right, so there are two practice problems for y'all to try. Go ahead and pause it, and then when you're ready, unpause the video and we'll go over them. All right, so let's see how you did. On the first one, we're given the zeros 2i and negative I. That should result in the factors x minus 2, x minus I, and x plus I. Now, when you multiply out the 2i quantities here, you should end up with an x squared that you can replace with a negative 1. So remember, when you subtract a negative, that becomes a positive. Okay? And then you just multiply the remaining two factors out, which should give you p of x is x cubed minus 2x squared plus x minus 2. The same thing on number 2. You're given three zeros, negative 5, square root of 3, and negative square root of 3. When you move those over, they result in the factors x plus 5, x minus square root of 3, and x plus square root of 3. And then you want to go ahead and distribute those out, and that will simplify down to x squared minus 3. And then we can go ahead and distribute those last two quantities. Be sure to write your polynomial in descending order, meaning the highest power of x down to the smallest power of x. Okay? All right, so now we want to look at going the opposite direction and putting some of that good synthetic division that we've been learning about to good use. Okay, so Now we're going to be given the polynomial, and we are going to be finding the zeros, okay? So there's two different strategies to find them, okay? And most of these are not going to be polynomials that we can factor normally, right? This is our second strategy. So one thing is if they go ahead and give us one of the zeros. If they give us one of the zeros, then we can just plug it in using synthetic division, and then we can find the remaining factors from the quotient that we get from that synthetic division. Okay. Now keep in mind, a lot of times once they give us a zero and we work it out and we get the quotient, it's something we can easily factor, but not always. Sometimes it's something we can't factor. So there's a couple of helpful hints to keep in mind that come from these theorems. One is the non-real zeros, meaning our I terms, right? So what this is saying is basically zeros and factors that contain complex numbers they appear in conjugate pairs. So meaning if I get x equals 7i as a zero, then we also know that x equals negative 7i is also a zero, right? Or if we end up with something like x equals 1 minus 5i, then that means that we would also have the 0, 1 plus 5i, okay? And it shows up in factored form also, okay? Now this is true for both I terms and for both irrational zeros, meaning when we have radicals. So if I have something like x equals the square root of 7, then that means x equals negative square root of 7 will also be a zero. Okay? Or sometimes you have a combination of the two. You might have something like x equals 3 minus I square root of 7, something like that, right? Then that means that x equals 3 plus I square root of 7 would also be a zero. Okay, so it's a really good, helpful information to keep in your mind that anytime you have an I term, you should have its plus or minus pair also as a zero. Or same thing with factoring, right? If you have a radical factor, you should also have the conjugate factor of that same radical. Okay, all right. So a couple of things to keep in mind. We're going to go over some that we're given a zero and go through how to factor and find the remaining ones. And then we're also going to go through a couple where we are not given a zero and we kind of have to start from scratch. Okay. All right. On this one, it says, given that a polynomial function has the given zero, find the other zeros. So they're telling us that x equals negative 5 is a zero. Okay. So we're going to go ahead and put negative 5 in our little synthetic box and write out all our coefficients. So we have a 1, a 5, a negative 2, and a negative 10. And I don't need any zero placeholders because I'm not missing any terms, right? So I bring down my first number, which is a 1. 1 times the negative 5 in my box is negative 5. That results in a 0. 0 times the negative 5 in my box is 0, which combines down to negative 2. Negative 2 times the negative 5 in my box is positive 10, which combines down to 0. So yay, it worked, right? They told us that x equals negative 5 is a 0. So that means we also found a factor, okay? If x equals negative 5 is a 0, if I were to write this as a factor by moving that 5 over to the other side, that means that x plus 5 is a factor. So every time they give you a 0, they're also helping you factor it, okay? So what this is telling me is that I can now write this original function in a little bit factored form, okay? So we have our original f of x, and we just found out that it factors into x plus 5. Now the remaining factor that I'm left with is this quotient here. So remember, this was my remainder. Negative 2 is my constant term, 0 is my x term, and 1 is my x squared term, which means I'm left with x squared minus 2 as my remaining factor. Now this is something we should be able to solve, right? Because if it's an x squared, we can quadratic formula, we can try to factor it, or we could even use the square root property here, which is what I'm going to do. So I'm going to go ahead and set this one equal to 0. So x squared minus 2 equals 0 to figure out what the remaining zeros are. So I'm going to move my 2 over by adding. So I get x squared is equal to positive 2. And then I can solve this by doing the square root as long as I don't forget my plus or minus. Okay? So what I'm ending up with is x equals the square root of 2 or x equals negative square root of 2. Okay? So there's two things I should be able to do from here. One, I found my other zeros, right? These are the other zeros that I was asked to find. But I should also be able to write this function fully factored now, right? Because the first factor, x plus 5, I got off of my first synthetic division. So this is x plus 5. And then now that I have my other two zeros, I should be able to move these across and write them as factors. So this would be the factor x minus square root of 2 and x plus square root of 2. So I was also able to completely factor this. Okay? All right, let's look at another one. So this one wasn't too bad. They give us a 0. What we're left with was something we could easily solve. I want to show you one that maybe doesn't turn out quite as pretty. Okay? So on the top of the next page, we have this one, and they give us a 0 of I. Sorry, negative I. Okay? So we're going to go ahead and start by putting negative I in our box. And remember, when we do i's, sometimes they look a little funky. So we're going to leave a little extra room when we're dealing with i's. So here's our 1, and then we have a negative 5, and then we have a 7, and then we have a negative 5, and then we have a 6. I'm spreading it out just a little bit because i's can kind of get funky looking. So I'm going to bring down my first number, which is a 1. 1 times the negative I in my box is negative I. Now here, when I combine down, I can't actually add these two together, right? Because they're not like terms. So I'm going to go ahead and just write them side by side. Negative 5 minus I. So now I need to take that negative 5 minus I and multiply it by the negative I in my box. And I'm going to do it below here so that I can think through it. So negative I times negative 5 minus I. When I distribute here, I'm going to get a positive 5i and a positive I squared. And then remember, I squared is negative 1, right? So this gives me 5i minus 1. So that's what I'm going to put up here below my next number. So I have 5i minus 1. And now my 5i can't combine with anything, so it's going to stay there. But I can combine my 7 and my negative 1 to get positive 6. So 5i plus 6 is now what I need to multiply by the negative I in my box. And again, I'm going to do it down here. So negative I times 5i plus 6. When I distribute that negative I get negative 5i. And, or sorry, negative 5i squared, right? And then negative I times 6 is negative 6i. We know that I squared is negative 1. So when I do negative 1 times negative 5, that makes this a positive 5 minus 6i. Okay, so that's what I'm going to write up here. So I have 5 minus 6i. And here again, I can't combine the I term with anything, but my 5s I can combine, and they actually combine to 0. So I'm left with just negative 6i. So now I need to multiply the negative 6i times the negative I in my box and write it here. So I'm going to do it down below. Negative I times negative 6i gives me positive 6i squared. And then remember, I squared is negative 1. So negative 1 times positive 6 makes that a negative 6, which I'm going to write up here, which does in fact give me the 0 that I need. Okay, so what we have found is that if this is a 0, right, if we're ending up with x equals negative I, then we've also found a factor, which would be x plus I, right? So we can now write our function just a little bit more factored than we did before, right? So we found this factor, x plus I, and the remaining factor that we have is what we got as our quotient here from synthetic, right? Now, the 0 was my remainder, the negative 6i is my constant term, the 5i plus 6 is my x term, right? My negative 5 minus I is my x squared term, and my 1 is my x cubed term. Now, this is pretty nasty, right? If I wrote this out, I would have x cubed plus negative 5 negative I times x squared plus 5i plus 6x minus 6i. And this is not something we're used to dealing with. This is not something that we've learned to factor or anything else. So we'd really like to be able to break this down just a little bit more because it's nasty, right? So if we don't know how to factor this, we want to think about, is there another way to come up with a 0, right? Well, remember, the 0 that they gave us originally was negative I. And we know that i's appear in conjugate pairs. So if negative I is a 0, then we also know, right, that x equals positive I should be a 0. So I'm going to go ahead and just break down this mess a little bit further by trying out positive I. Now, I'm not going to put positive I and use the original coefficients because I've already broken this down a little bit, right? I've already found one of the factors. What I need to break down further is this mess. So this is what I'm going to put my negative I into with synthetic division to see if I can break this down into something more manageable. Okay, so I want to write out all my coefficients. So my x cubed term is a 1. My x squared term is a negative 5 minus I. My x term is a 5i plus 6. And my constant term is a negative 6i. Right? Or you can just copy these down from the synthetic we got over here, right? All right, so we're going to leave a little space and draw a line. We're going to bring our first number down, which is a 1. 1 times the I in my box is positive I. And notice when I combine down, my i's cancel, and I'm just left with negative 5. So negative 5 times the I in my box gives me negative 5i. And again, notice my I terms cancel when I combine down, and I'll just get 6. 6 times the I in my box is a positive 6i, and that combines down to 0. So yay, I got another 0 of this function, which also means that I have found another factor, right? If x equals I is a 0, then that means x minus I is a factor. So I'm going to go ahead and write this again, just broken down a little bit more. So we have our f of x is equal to the first factor, x plus I, that we got from our first synthetic, right? Now, times our next factor, which is x minus I, times my leftover factor, which is my quotient down here. So this is my constant term, this is my x, this is my x squared. So we're left with x squared minus 5x plus 6. And now I just need to see if I can break down this last little bit to find the other two zeros, right? So if I take x squared minus 5x plus 6 and set that equal to 0, this is something I know how to solve. I can try sum product, and if that doesn't work, then we can try quadratic formula, okay? So my sum is negative 5. My product is 6. So I'm going to need something that multiplies to a positive 6 that combines to a negative 5, which would have to be negative 2 and negative 3. And because my leading coefficient is a 1, I can use my shortcut, which says this factors into x minus 2 and x minus 3. Right? So these are the remaining factors. So I should be able to go ahead and, I'm going to go ahead and write this completely factored. So I have x plus I, x minus I, and then we just found that this piece factored into x minus 2 times x minus 3. And now I can solve each of these to find the remaining zeros, right? Which would give me a positive 2 and a positive 3. So aside from the negative I0 that they gave us, the other zeros that we came up with was the positive I and then the 2 and the 3. So our zeros here, and I'm going to say other because one was given to us, was the I, the 2, and the 3. Okay, and that's all we have to do. All right, so there is one practice problem for y'all to try really quick on finding the remaining zeros. Go ahead and give that a whirl, and when you're ready, unpause it and we'll go over it. All right, so let's see how you did. On this practice problem, they give us the 0 of x equals 1. So since we know x equals 1 is a 0, we also know that x plus 1 is a factor. But we're going to go ahead and put our 1 in the synthetic box, and do our synthetic division, which leaves us with x squared plus 1 as my quotient, right? So that means I should be able to factor my function into the factor we get from the given 0, which is x minus 1, times our quotient that's left under here, which was x squared plus 1. And then the x squared plus 1 we can go ahead and solve by just setting it equal to 0 and solving. And then once we have our two remaining zeros, which is plus and minus I, we should be able to write those as factors. So that gives us x plus I and x minus I. So we have it completely factored, and we know what those other two remaining zeros were that weren't given. Okay? All right, so this is kind of the good situation. This is the good option where we are given one of the zeros and we just have to find the other ones. And that's not always the case. A lot of times there is no known zero. No zero is given to us. So if there is no zero given to us, we have to come up with the zeros on our own. Now, we don't want to just start, on these other ones, whatever the given zero was, we plugged it into synthetic, verified that it gave us a 0 remainder, and then went on from there. Well, how do we know what that first zero is going to be, right? There's infinite numbers to choose from mathematically. Like, do I plug in 25? Do I plug in 1/5? Do I plug in -7? Like, how would we know what's a zero? So there's a way to come up with not necessarily the actual zeros, but a short list of potential zeros, meaning I'm going to come up with a short list of numbers that could be zeros. Instead of having to choose from infinite possibilities of all the different numbers that are out there, rational, irrational, whatever, I'm going to get this little short list of nice, pretty numbers that I can check with synthetic. And once we get one to work, then we work it just like we did the last problems, okay? So here's how we come up with our short list of nice, pretty rational zeros. It's called the rational zeros theorem. And what we do is we make sure that our polynomial function is written in descending order. And all we're going to use is our constant term, right? This is our constant term. And our leading coefficient, okay? So the way that we come up with this short list is we look at all the factors of our constant term and we divide them by all the factors of our leading coefficient, and that will create a list. Okay, and instead of writing out all the possible positive factors, all the possible negative factors, we're just going to put plus or minus in front of it. That way it kind of accounts for both. Okay, all right, so let's look at how to do this. For example, let's say this is the polynomial that we're trying to create a short list for. Okay, so what I would do in order to find all the possible rational zeros is I'm going to do plus or minus all the factors of my constant term. So in this case, I would be looking at factors of 6 because 6 is my constant term. And then I'm going to divide those by all the factors of my leading coefficient, which in this case is 10. Okay, so that's all you have to remember. If you get help on my math lab, it's going to give you this theorem. It's going to talk about P and Q and all this craziness. All you need to know is that it's the factors of your constant term, that's your P, over the factors of your leading coefficient, and that's what they call Q. Okay, so let's write it out. So all the factors of 6, everything that goes into 6 would be 1, 2, 3, and 6. Those are all the possible factors of 6. And then we want to write it over all possible factors of 10, which would be 1, 2, 5, and 10, right? Okay, so now I want to see what this combination, what kind of numbers it will create. Okay, so to figure out all my possible ones, I'm going to write out all the combinations if I divide these. So I'm going to start with 1. If I do 1 divided by 1, I get 1, right? 1 divided by 2, I get 1/2. 1 divided by 5, I get 1/5. 1 divided by 10, I get 1/10. Now I want to do 2. 2 divided by 1 is 2. 2 divided by 2 is 1, which we already have listed here, so I'm not going to list it again. 2 divided by 5 is 2/5. And 2 divided by 10 actually reduces, 2 over 10 reduces to 1/5, and we already have that. So now I'm going to move on to 3. 3 divided by 1 is 3. 3 divided by 2 is 3/2. 3 divided by 5 is 3/5. And 3 divided by 10 is 3/10. And then I'm going to do 6. 6 divided by 1 is 6. 6 divided by 2 is 3, which we already have. 6 divided by 5 is 6/5. And 6 divided by 10 reduces. 6 over 10 reduces to 3/5, which we already have. So this is my short list. Okay. Now again, this is not saying that all of these numbers are going to be zeros. This just says, here's a short list of numbers that you can try. They might be zeros versus just picking random numbers from the universe, right? Okay, so what we would do from here is we would say, okay, let's plug 1 in using synthetic division and see if it gives us a 0 remainder. If not, okay, let's try -1 and see if it gives us a 0 remainder. If not, we try 1/2 and then -1/2 and then 1/5 and then -1/5. Does that make sense? So this just gives us our short list of numbers to try to plug in until we get one that works. Okay. All right, so there's one right here. Go ahead and take just a couple minutes and work it out. See what your possible zeros are. We're not going to work it all the way out. Just tell me the plus or minus listing of the possible zeros. And then go ahead and unpause it and we'll go over it. Okay, so we're looking at all the factors of our constant term, which in this case is 8, divided by all the factors of our leading coefficient, which in this case is 2. So all the factors of 8 are 1, 2, 4, and 8. All the factors of 2 are 1 and 2. Okay, so we start dividing these, right? If I do 1, 2, 4, and 8, and I divide all of those by 1, I'm going to get 1, 2, 4, and 8, right? And then when I take 1 divided by 2, I get 1/2. And when I do 2, 4, and 8 divided by 2, I'm going to get numbers I already have listed. So we should have 1, 2, 4, 8, and 1/2. Now, if you didn't list yours in that perfect order that matches mine, that's okay. As long as you got all 5 of these numbers, that's what I'm looking for. Okay. All right. So now that we know how to find the short list, now I want to do a couple of examples of taking you through the whole process. So from here on out, we no longer can say, oh, this is not factorable and just stop. Okay. Because now we have a method for fully factoring any polynomial function. Okay, so we start by finding all the possible zeros, and then we plug them in until we find one that works. And then hopefully once we find one that works, our quotient that we're left with under that synthetic division will be something we can factor. Okay, all right, so let's look at the first one. And on all of these, our instructions are for each polynomial function, find all possible rational zeros. Okay, that's the plus or minus thing. Okay, then we want to use them to determine the actual zeros, both rational and other. Okay, and then we want to write the function as a multiplication of linear factors. Okay, that means we want to fully factor the function. We want to write f of x equals factor times factor times factor times factor, right? Okay, all right, so let's start by finding all of our possible zeros. So to find all of our possible zeros, we do plus or minus all the factors of our constant term, which is 5. So that would be 1 or 5. And we're dividing that by all the factors of our leading coefficient, which is 3. So factors of 3 would just be 1 and 3. Okay? So that means that our possible zeros would be plus or minus. I'm going to write out all the options. So if I take 1 and divide it by 1, I get 1. 1 divided by 3, I get 1/3. 5 divided by 1, I get 5. 5 divided by 3, I get 5/3. So this short list is actually pretty short. That's good. All possible zeros, that means even if I had to plug in every single one, I'd have to plug in 1, 2, 3, 4, right? And then their negative version, so 8 possible. So that's not too bad. All right, so let's start with 1 and see if we can get, if we can find a 0. So if I put 1 in my little box, I'm going to write out all my coefficients. Notice I'm not missing any powers of x or the constant term, so I don't need any 0 placeholders. So I put in 3, -1, -15, and 5. So I go ahead and bring down my 3. 3 times the 1 in my box is 3. I combine down and get 2. 2 times the 1 in my box is 2. I combine down and get -13, right? -13 times 1 is -13, and this is not going to give me a 0, right? So this did not work out. So now let's try -1. Let's put -1 in our box and write out all of our coefficients here. So I bring down my 3. 3 times the -1 in my box is -3. -3 and 1 give me -4. -4 times the 1 in my box is +4, which gives me -11. -11 times the 1 in my box is +11, and that is also not going to give me a 0. Okay, so let's try our next one, which is 1/3. So I'm going to put 1/3 in my box and write out my coefficients. Okay, we haven't done one with a fraction yet, I don't think, but we do it the exact same way. We bring down our first number, 3. 1/3 times 3, or 1/3 of 3, is 1. We combine down and get a 0. 0 times 1/3 is 0, which combines down to -15. -15 times 1/3, or 1/3 of -15, would be -5. We combine down and we get our first 0. Yay! And there's great rejoicing. Okay, so what do we just find? What does that mean? If we got a 0 remainder, that means this number in my box, x equals 1/3, is a 0. Woo woo! So we need to figure out what it is as a factor. Now, with a fraction, it gets a little bit more complicated than just moving the 1/3 over, okay? We want to find the factor. So it's like we're undoing what's been done here. So first I would clear fractions by multiplying both sides by 3. So this gives us 3x is equal to 1 if I multiply both sides by 3. And then I move my 1 to the other side. So this gives me 3x minus 1 equals 0, right? Which means that 3x minus 1 is my factor. Okay? All right, so let's go ahead and write what we've done. We've factored this just a little bit. So now I should be able to write my function f of x as the factor we just found, which is 3x minus 1, times this remaining factor, right? So this was my remainder, this is my constant, this is my x, this is my x squared. So this gives us 3x squared minus 15. Okay, and now all we need to do is finish factoring this. Okay, and the first thing that I notice when I need to finish factoring this is that this actually has a greatest common factor, right? If it has a greatest common factor, we definitely need to pull that out. So the greatest common factor is a 3. So I'm going to pull that out first, and we always write our greatest common factor at the beginning. So I'm going to write it in front of this first factor, which is 3x minus 1. And if I take out that 3, that leaves me with x squared minus 5. right? And then this is something I can solve just by taking the square root. So I'm going to go ahead and set this equal to 0. So x squared minus 5 equals 0. I move the 5 over, so I get x squared equals positive 5. And then I take the square root. Don't forget your plus or minus. Okay, so I found 2 more zeros, right? This gives me x is equal to the square root of 5 and x is equal to the negative square root of 5. So since I got 2 more zeros here, I should be able to write this as 2 new factors. So I have my original function, the greatest common factor that we found, the first factor that we got from our first synthetic, and then now the 2 factors that came from these solutions, which would be x minus the square root of 5 and x plus the square root of 5. Oop, 5, not 2. Okay, that looks horrible. Let me fix it. This is why teachers have whiteout. 5. Okay. All right, so here's my fully factored version. And then I just need to list all my zeros. So the first 0 I got was up here, the 1/3 that I got from doing synthetic, right? So I'm just going to say my actual zeros, because we're no longer talking about the short list, right? These were not actual zeros. These were just possible zeros. So the actual zeros we got was the 1/3 that we got from synthetic and the square root of 5 and the negative square root of 5, right? Which is kind of crazy if you think about it, because since the only rational zero we got here was 1/3, that means if we would have checked all of these numbers in both the positive and negative version, 1/3 is the only one that would have worked. Crazy. All right, let's look at another one. I'm going to look at the one on the next page, and then I'm going to have y'all try a couple before I do a really hard example. Okay, so let's look at one more. Let's look at the one on page 30. Haha. Okay, so first thing we want to do is find all possible rational zeros to create that short list. So possible zeros, we do plus or minus the factors of the constant term, which here's 4. So 1, 2, and 4 are the factors of 4, divided by the factors of my leading coefficient, which is 5. So 1 and 5 are the factors of 5. So we're going to go ahead and write out all the possible zeros. So we do plus or minus. I'm going to take 1 and divide it by 1 and 5. So that's going to give me 1 and 1/5. Then I'm going to take 2 divided by 1 and 5. So that's 2 and 2/5. And then I'm going to take 4 and divide it by 1 and 5. So that's 4 and 4/5. So this is my short list of possible rational zeros. And now I want to start plugging them in until I find one that works. Okay, so I'm going to go ahead and plug in my 1. I'm going to write out all my coefficients. So I have 5, -6, 21, -24, and 4. So I bring down my first number, which is a 5. 5 times the 1 in my box is 5, which combines down to -1. -1 times the 1 in my box is -1, which leaves me with 20. 20 times the 1 in my box is 20, which combines down to -4. -4 times the 1 in my box is -4, which combines down to 0. So yay on the first try. Yay. So what this tells me is that x equals 1 is a 0, and that x minus 1 is a factor, right? Because I just take my 0, move it back across the equal sign. Okay, so I'm going to go ahead and rewrite this a little bit factored. So now we can say that f of x is equal to this new factor that we just found, which is x minus 1 times the remaining factor. And the remaining factor is what we have up here that's left over from synthetic. So remember, this is our remainder, this is our constant, this is our x, this is our x squared, this is our x cubed. So this leaves me with 5x cubed minus x squared plus 20x minus 4. okay? And now this is something we should be able to factor, right? Because there's 4 terms here, so we can try factor by grouping. So when I factor the first 2 terms, I can take out an x squared, which leaves us with 5x minus 1. And then out of the next pairing, I can take out a positive 4, which leaves us with 5x minus 1. So now they both have a 5x minus 1. So if I take out the 5x minus 1, I'll be left with x squared plus 4. Okay, and then don't forget this other factor here of x minus 1. Okay, so now we're a little bit more factored, right? So we already solved this one. That's the one we got from synthetic. We now have this new one that we can set equal to 0 and solve. And we have this new one that we can set equal to 0 and solve. So on our first one, we move the 1 over, make it positive, and then divide off our 5. So we get x equals 1/5. And then on the second one, we move our x over, which makes it negative, and then we can get rid of the squared on that x by taking the square root. Now don't forget your plus or minus when you do this. Negative under a square root comes out as an I, and the square root of 4 is 2. So this gives us plus or minus 2i. Okay, so now we know all of our actual zeros, right? We had the 1 that we got from synthetic, and then now we have 1/5, and then we also have plus or minus 2i. So we found all the actual ones. The last thing we need to do is get this thing fully factored. So we have f of x is equal to the factor we got from synthetic, which was x minus 1, our 5x minus 1 factor. And then instead of writing x squared plus 4, because we got 2 solutions out of it, we can make 2 factors out of each solution. So this is going to give me x minus 2i and x plus 2i as my remaining factors. So we're going to go ahead and leave it just like that. Okay. Now, I know there's one more example on page 31, but I'm going to go ahead and hold off on that one for just a second. I want y'all to go ahead and work practice problems number 1 and 2, and then we'll go over those, and then we'll dive into that last example and the practice problem that's a challenge. Okay? Go ahead and pause it, give those a spin, and then we'll go over them. Okay, so on the first practice problem, we start off by finding all the possible factors of 6 over all the possible factors of 1. And you could use -6. 6 and -6 have the same factors, so I would just look at the positive version because we have the plus or minus here to account for both. Okay, so all the factors of 6 divided by all the factors of 1 really just give us all the factors of 6. So when you start plugging in your synthetic, the first one, and really the only one that should work, is -3. -3 gives us a 0 remainder. So x equals -3 is a 0, and x plus 3 is a factor. So we write the factor that we found times the quotient we're left with under here, which is an x squared minus 2. And then that x squared minus 2 we can set equal to 0 and solve to get plus or minus the square root of 2. So our actual zeros are the -3 we got from synthetic and the plus or minus the square root of 2 we got from solving the remaining factor. So we should be able to write these three zeros as factors, which would be x plus 3, x minus the square root of 2, and x plus the square root of 2. Okay, let's go ahead and look at the second practice problem. This one was a little bit easier, right? We start plugging in things. I didn't show my work for plugging in 1 and 2. Excuse me. I went ahead and started with -2. -2 gives you a 0 remainder. And then what's left over here, what we need to factor, is x squared minus 2x plus 4, right? And this is actually not factorable using sum product. So we have to use a quadratic formula to finish this one out. So we plug in to our quadratic formula. Make sure you simplify the radical. There should be an I that you can pull out. and the square root of 12 simplifies to 2 square root of 3. Okay, and then you should be able to reduce all three terms here by 2. So we end up with 1 plus or minus square root of 3i as our remaining zeros. Okay, so we end up with the negative 2 that we got from synthetic, the 1 plus 3i, and the 1 minus 3i that we got from the quadratic formula. And then once we have these two factors, we should now be able to, or sorry, these two solutions, we should be able to write them as factors. So remember, it's like saying x equals this and x equals this, and we would have to move the 1 and the radical to the other side. So we would end up with x minus 1 minus 3i and x minus 1 plus 3i. Make sure all of your factors have a variable, okay? All right, so now that we got a little taste of it, let's look at one that's a little bit more complex to do, and I'll give y'all a little bit more complex example to try. All right, so on page 31, we're going to start it just like we did all the other ones. Start by finding all the potential or all the possible zeros. All the possible zeros we get by doing all the factors of our constant term divided by all the factors of our leading coefficient. Now here our leading coefficient's 1, and the only factor of 1 is 1. So if I take all the factors of 20 and divide them by 1, I'm just going to get all the factors of 20. So I'm going to go ahead and just write out all the factors of 20, which would be 1, 2, 4, 5, 10, and 20. So here's my short list of stuff I'm going to start plugging in, okay? So I'm going to start with 1. Sometimes we get lucky and 1 works. And I'm going to write out all my coefficients. Notice I'm not missing any terms. So I have a 1, a negative 5, a 5, a 15, a negative 36, and a 20. I'm going to draw my line, bring my first number down, which is a 1. 1 times the 1 in my box is 1, which leaves me with a negative 4. Negative 4 times the 1 in my box is negative 4. I combine down and get 1. 1 times the 1 in my box is 1, which gives me 16. 16 times the 1 in my box is 16, which leaves me with a negative 20. And negative 20 times the 1 in my box is negative 20. So we get our 0. Yay! So what we discovered is the number in our box is a 0. X equals 1 is a 0, and as a factor that would be x minus 1 is a factor. Okay, so we can go ahead and break down our function a little bit. So f of x is equal to the factor we just found, which is x minus 1, times our remaining factor here, right? This is our constant, our x squared, our x cubed, our x to the 4th. So what we're left with is x to the 4th minus 4x cubed plus x squared plus 16x minus 20. Now, on all the other examples, once we got one of the zeros to work, we were able to factor whatever's left here, right? But in this case, we're not, because we're left with 1, 2, 3, 4, 5 terms. We've never done any factoring with 5 terms, right? We've only done it with 4 so that we can group like the first 2 and the second 2. We've never done 5, so we don't really have a clue how to do that. So what we're going to do is instead of taking this and trying to factor it, because we have no factoring method for it, I want to try to continue to break this down by using synthetic division again. So notice, again, my constant term is still 20. My leading coefficient is still 1. So I can still use the original possible zeros and start plugging them in. Okay? So I already did 1. Now there could be multiple copies of 1. But if so, that will come out. So I'm going to go ahead and just try negative 1, just to try something different. So negative 1. So we have 1, negative 5, 5, 15. Oh, no. I'm messing up. Don't listen to me for 2 seconds. Okay, I want to further break down this piece. So I'm not going to use the original numbers. I want to use these numbers of this polynomial that I need to further factor. So this leading coefficient is a 1, and then a -4, and then a 1, and then a 16, and a -20. So I bring down my first number, which is a 1. 1 times the -1 in my box is -1, which gives me -5. -5 times the -1 in my box is 5, which gives me a 6. 6 times -1 is -6, which gives me 10. 10 times -1 is not going to give me a 0, right? That didn't work. All right, let's try 2. So 1, -4, 1, 16, -20. Bring down my first number. 1 times the 2 in my box is 2, which combines down to -2. -2 times the 2 in my box is -4, which gives me a -3. -3 times the 2 in my box is -6, which leaves me with a 10. Times the 2 in my box is 20, and that's going to give me the 0 that I needed. Yay! So this tells me that x equals 2 is a 0, which means that x minus 2 is a factor, right? So we found another factor. So let's go ahead and write this broken down a little bit more. So we have our original function times the first factor we found up here, which was x minus 1, times the second factor we now found of x minus 2, times the remaining factor of my quotient, what I have left here. So this is my constant, this is my x, this is my x squared, this is my x cubed. So I'm left with x cubed minus 2x squared minus 3x plus 10. Okay, and this should be pretty good news, right? Because we're down to 4 terms, and 4 terms we can use grouping. But if you notice on this one, if I were to group the first 2 terms, I could pull out an x squared, which would leave me with an x minus 2, right? And if I come over to this grouping, there is nothing I can pull out that's going to leave me with an x minus 2. So this one, even though it has only 4 terms, it's not factorable by grouping. So if it's not factorable by grouping, we have to keep going with synthetic. Okay, so I'm going to say this piece right here is not factorable by grouping. And we're just going to say keep using synthetic. Okay. All right. So the good news is it did break down a little bit, because notice now my constant term is a 10. So out of all these, I no longer have to worry about the 20, right? Because 20 is not going to be a factor of 10. It's not a number we have to check. But it could still be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, right? Now, we've already done 1 up here. We've already determined -1 doesn't work. And if it didn't work up here, it's not going to work now. And we already tried 2. So our next one is, let's try -2. So we're going to put -2 in our box. And remember, we're trying to further break down this one. So these are the coefficients we're going to use, which is 1, -2, -3, and 10. Draw my line, bring my first number down. 1 times the -2 in my box is -2. It gives me a -4. -4 times the -2 in my box is a +8, which leaves me with a +5. And 5 times -2 is -10. So yay, we got another one. Yay, great rejoicing, right? So this tells us the number in our box, x equals -2, is a 0. So as a factor, that would be x plus 2. Okay. All right, so let's see where we're at now. Factoring this guy. So our original function is equal to the factor we got from our first synthetic, which was x minus 1, the factor we got from our second synthetic, which was x minus 2, and now this factor that we got from our third synthetic, which is x plus 2, times our remaining factor, which is what we get here from synthetic. So this is my constant term, my x, and my x squared. So I'm left with x squared minus 4x plus 5. And now I can just factor this, right? I should be done with synthetic because once I get down to an x squared, I should be able to factor using sum product or the square root method or quadratic formula or something, right? I shouldn't have to do synthetic anymore. So let's go ahead and look at doing sum product with this. My sum is -4 and my product is 5. Now it's a positive 5, so the only thing I can multiply to get a positive 5 would be 1 and 5. And that does not give me a -4, right? So if that does not give me a -4, then this is not factorable using the sum product method. So we're going to have to use some other method. So I'm just going to say, let's use the quadratic formula. Okay, so to use the quadratic formula for this, x is equal to the opposite of my b, so the opposite of -4, plus or minus the square root of my b, -4 squared, minus 4 times my a, which is 1, times my c, which is 5, all over 2 times my a, which is 1, right? And then I just need to simplify. So this gives me a positive 4 plus or minus the square root of 16 minus 20, all over 2. 16 minus 20 is a -4, so I have 4 plus or minus the square root of -4 over 2. -4, I can take out an I and simplify this to a 2. So I have 4 plus or minus 2i over 2. And notice all three terms are reducible by 2. So I end up with x is equal to 2 plus or minus I. Okay, so those are my two remaining zeros. Those should also be able to give me two factors so I can get this whole thing factored. Okay, so f of x is equal to my first synthetic factor, my second synthetic factor, my third synthetic factor, and then the factors that I get from these solutions. So I would have my x. When I move my 2 over, it becomes a -2. When I move a positive I to the other side, it becomes a negative I. And then I'll also get an x minus 2 plus I. So that is my fully factored version. And then my actual zeros are from the very beginning. We got 1, and then we got 2, right? And then we got -2, and then we ended up with these two complex solutions. So we should have a +1, a +2, a -2, a 2 plus I, and a 2 minus I. Okay, so I know this kind of looked like a painfully long, ridiculous process, but all it's saying is that if we are left over with something we cannot factor, we can continue to keep doing synthetic to help further break it down by one factor at a time. Okay? All right, so now that we've done the one on page 31, you should now be able to attempt the practice problem, the challenge problem, okay, on page 34, which was your third practice problem. Just go ahead and pause the video and try that one whenever you're ready to be checked, or if you get stuck, play the video and we'll go over it, okay? All right, sorry if this looks teeny tiny. I wanted to be able to get the whole thing on there. So first thing we wanted to do is find the possible factors. So we're looking at the factors of 24 over the factors of 1, which is really just the factors of 24. Make sure you put plus or minus out here because they could be positive or negative factors, right? And then we just start plugging them in until we find one that works. And I had to plug in all the way down to -3 until I got one that works. So -3 is a 0, which means that x plus 3 is a factor. So I should be able to rewrite this original function as the factor that I just found times the quotient that was left over here in my synthetic. So I have my 1x cubed minus 6x squared plus 10x minus 8. And this is not factorable by grouping. we try to group these together, it's not going to work out for us. So if it's not factorable by grouping, we want to continue going with synthetic. Now, I don't know how many you had to plug in until you found one that worked, but 4 should be the next 0 that works. So it gives us a 0 remainder. So now we can break it down a little bit further. My x plus 3 factor that I got from my first synthetic times now this next factor that I got from finding that 4 is a 0. That means x minus 4 is a factor. And what I'm left with is my quotient that I got from doing my synthetic with 4, which is x squared minus 2x plus 2, which is not factorable using our sum product method. And so we have to use quadratic formula. So when we go through the quadratic formula and simplify, we should end up with 1 plus or minus I. So our factors are the x plus 3 we got from our first synthetic, the x minus 4 we got from our second synthetic, and then our x minus 1 minus I and x minus 1 plus I that we got from our solution from the quadratic formula. Okay, so our actual zeros are the -3, the 4, and then the 1 plus or minus i's solutions. Okay. All right, so that is the end of section 4.4. There is a math lab assignment as well as a worksheet that goes with this function, okay? And just a note on the worksheet, here's your heads up on how I'm grading it. I am going to grade it just like I did the last one. I'm looking for the whole process of graphing a higher order polynomial, meaning I want to know the end behavior. So look at the leading term, tell me if the ends are together or opposite, and then I want you to find the zeros. Now, because this is a section 4.4 worksheet, it's not going to be a problem that you can factor with grouping or anything like that. It's going to be one that you're going to have to go through this process in order to find those zeros. Once you find those zeros, you should be able to look at your factored function and determine the multiplicity, if it touches, if it crosses. And then just like the last worksheet we did in section 4.2, I want you to tell me not only the end behavior and the multiplicity of your zeros, but also plug in some additional test points and find your y-intercept so that we get an accurate sketch of whatever this function looks like. Okay? All right. So if you have any questions, please let me know. Otherwise, we'll see you on the next video.